All right, ladies and gentlemen, welcome back. We're working on example 3, and we're going to find the probability of complements. Really what that means is we're taking a not statement and turning it into a true statement. So, for example, in A, it says the sum is not 6. We've got the idea that we're rolling 2 dice, and there are 36 possible outcomes. If you look at the dice are in red, and it's just illustrating what's possible. So we're supposed to find the probability of each event. The first one is the sum is not 6. Well, if you look at it, the sum is not 6. Well, that sum is not 6 there, nor here, nor here, nor here. It is there. It's not here, 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 here. And as you can see, there's going to be a lot to look at. Oh, I'm just going through and highlighting them all just so you can see all those blue ones is the probability that it's not 6. Now, instead of finding not 6, what I could do is I could find the probability that it is 6 and take that away from 1. Because if I find the probability that the sum is 6, everything else outside of that probability is the sum that it's not 6. It's like a Venn diagram, okay? This is where it doesn't overlap. It's just what's in its own circle. So what we're looking at here is finding the sum of what is not 6 is the same thing as 1 minus the probability of the sum is 6. So we know there's 36 possible outcomes, and there's, let's see, color coordinate. 1, 2, 3, 4, 5. 5 of them, that sum is 6. And if I take 1 minus this, that's going to be the same thing as finding, in this case, 36 over 36 minus 5 over 36, which is going to get us 31 over 36. Now, that ends up being equal to 0.861 or 86.1%. Now, if we're going to find the sum less than or equal to 9, let me get rid of all this up here. There we go. Now we're using the same die, or the same count, and we're finding the sum less than or equal to 9. So anything less than or equal to 9, well, that's going to be a lot of them, because here, 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 and just keep going. I could go through and do the same thing. But again, that's going to be more counting, so it's going to take longer than just finding the sum that is not less than or equal to 9, or the sum that is greater than 9, because that just ends up being, oops, put my highlighter back on. Right there. So we only have 1, 2, 3, 4, 5, 6. So if I take 1 minus the probability that the sum is greater than 9, well, I know there was 36 rolls and there were 5 of them. Ooh, 5? No, 6. Ooh. 1, 2, 3, 4, 5, 6. Yep, 36. All right. So again, I can replace that 1 with 36 over 36, and I get the same thing as 30 over 36, which is the same thing as 5/6. Now 5/6 is going to be 0.833 or 83.3%. Now, what I see is I actually have a better probability of rolling a non-6 than I do of anything greater than 9. Or sorry, less than or equal to 9. Which is kind of weird, but that's how it works out.